Assalamu alaikum, dear friends. Hoping that you are all fine with the blessings of Almighty Allah. And we have started already this paper 6, and we have solved already first two questions, and now we will be going to solve question number 3. Let's start. By the way, the exam is 0625 IGCSE paper 6 variant 3 and October-November 2024. October-November 2024. Let's move to question number 3. And here this question is basically about the light. Question number 3 is in front of us, and I'm sure all of you can hear me well. A student investigates the refraction of light by a transparent block. Transparent block, it means most probably it is glass block. He determines a quantity known as refractive index of the material of the block. The student's ray trace sheet is shown in full size in figure 3.1. So here you can see this is ray trace sheet in full size, figure 3.1. A, B, C, D is actually the transparent block, and then some incident rays are drawn, some pins are placed. We will be seeing it one by one. Now, he determines the quantity known as refractive index. Refractive index is basically denoted by letter N. I'm just talking about from paper 2 and 4 point of view at the same time. And one thing which is important related to this refractive index, this is one of the quantities in our syllabus of IGCSE physics which is not having any unit, because it is a ratio between two same quantities. Either it is a ratio between two speeds, or it is the ratio between two sine angles like this. Even it can be the ratio between two lengths. So it has no unit, and one of the only, I think, two quantities are there with us in IGCSE physics which are without any unit. One is this refractive index, another one is magnification. That is also related to the block 3, physics of waves. Anyhow, so the student ray trace sheet is shown full size in figure 3.1, and you can see it here in front of you. And I'm going to reduce the view of this one so that we can see the whole, actually the diagram. Now, the student places a transparent block ABCD near the center of the ray trace sheet as indicated in figure previous page, and it is at the center of this ray trace sheet, and draw a normal, which means 90 degree, to the point N extending above AB. Label the upper end of the normal with the letter L. So we are not going to do anything from our side. Paper 6 especially, not the default perception in your mind. We have to just follow the instructions given by the examiner. So first of all, I'm going to draw the normal mean 90 degree to the side AB and at point N. And where is point N? You can see this is the point N. Point N. Now I will be drawing here a normal at point N. Normal means 90 degree. It can be dotted line, it can be straight line, whatever. So normal is drawn, and it is said that the upper end of this line, upper end of the normal, we are supposed to denote it with or label it with letter L. So here I'm writing this capital letter L, and especially in this refraction of light as well as in reflection of light, we have to be very careful regarding the alphabets which are used to label particular points in the diagram. Next, extend the normal downwards until it crosses the line CD. Label the point at which it crosses the line CD with the letter F, and that's what I have already done. So here where it crosses the line CD, here we will label it with letter F. So by just drawing this normal correctly, we have scored how many marks? 1 mark. Now the student draws line EN as shown in figure, and it is drawn by the student already. EN, this is E, and here this normal where it is drawn, that is N. Now on figure 3.1, measure the acute angle theta 1 between the lines LN and EN. Acute angle is always less than 90 degrees. Acute angle is always less than 90 degrees. So dear friends, how to measure this angle? There can be many ways, but what we will follow, we can draw it by using the protractor, commonly known as D, and we will measure. But how you will keep the protractor? Please attentive here. You can use the protractor by this way, like put it such that the center of the protractor is placed at N, and you are placing the baseline of the protractor, baseline of the protractor, that is on LF. Let me say that is on LF, baseline of the protractor. Then like this, I have placed it this way. Now you will read here, two words are written, 0 as well as 180. Two numbers are there. You are not going to use 180, you are going to use 0. You are starting from 0, 0, 10, 20, 30, like this. That one option or line you are going to use. And when we are going to measure this angle, this is almost equal to 16 degrees. Almost equal to how much? 16 degrees. Better to put the protractor this way, such that the baseline, here 0 to 180, and here also it will be written 180, 0. So both the ways, both sides. So this is the baseline which is connecting 0 to 180, or you can say 180 degrees to 0. It should be on the normal line with the center of that protractor at N. Because more professionally, like in mathematics, you are naming this angle as angle ENL or angle LNE, because angle is measured at N. So the central point of the protractor must be at N. 16 degree is the angle. So I'm going to write it here as what? Here it should be as 16 degree. So 16 and very correctly degrees. Okay. The student places the two pins P1 and P2 on the line EN as shown in figure 3.1. Measure the distance D between the pins P1 and P2. So when we are going to measure this distance D between P1 and P2, where is basically P1 and P2? You can check, this is P1 and this is P2. As we measure the distance here, and I'm getting it because this diagram is not, I have just squeezed it. So let me make it to its comparatively bigger size. So now when I'm measuring this length, my dear friends, it is coming to be for me almost 3.6, and don't forget to write unit, which is centimeters. Suggest whether the two pins are suitable distance apart for accurate ray tracing. Explain your answer. Statement will be no. Statement will be no, because what is the explanation? For accurate ray tracing for refraction or reflection of light, the distance between the two pins must be at least 5 centimeters. So here it is not exactly 5 centimeters. So for accuracy, we need to put the pins or insert the pins at a distance of at least 5 centimeters. So you can say, for accuracy, pins must be placed at least 5 centimeters apart. Then my dear friends, next is the student views the images of pin P1 and P2 through the block. He places two pins P3 and P4 so that the pins P3 and P4 and the images of P1 and P2 all appear exactly one behind the other if we look from P4. So they are in line. Draw a straight line joining line through P3 and P4. Extend this line to cross NF. To cross NF. Label the point at which this line meets NF with the letter G and label the point at which, okay, one by one. So first of all, we are supposed to follow the instructions. He's saying join the points P3 and P4 and keep on stretching it till it touches the NF line, mean this line, NF line. Okay, dear friends, now I will keep on changing these different colors so that the things are very clear. Now NF, this way we need to go. I have drawn it roughly because I'm doing it on screen. So NF, we have to extend it till it crosses NF. So it has reached NF. Now what is said next? It is said that label the point at which this line meets NF with the letter G and label the point at which this line crosses CD with the letter H. G and H. What point is, which point is G? Now dear friends, this point where it crosses, so this is G, and where it crosses CD, this point is H. Don't forget to label any alphabet according to the given circumstances or according to the examiner's statements. Join the points H and N with a straight line. Which points? H and N with a straight line. Where is H? This is H, N is at the top, so I need to join them with a straight line. So I'm going to do the same thing. C from N to H. Yes, N to H, this blue line is the actually required line. N to H. Then what is next? Next is, now measure the length A of the line HN and measure the length B of line HG. HN first. HN first. I'm going to measure this length on this. God, this is simply a practice. You know, my lines are not exactly according to the, some answers will be definitely different from mark scheme's point of view. So for me, this HN is 6 centimeters. HN is 6 centimeters. I'm going to write 6.0. Now HG. HG, that is, my dear friends, for me 4.5 almost. So 4.5 centimeters. Now calculate a value N for the refractive index using the equation N is equal to A over B. N is equal to A over B. A over B. So what is A? That is 6. And what is B? 4.5. And as we are calculating, so 6 divided by 4.5, that is 1.33. So 1.33, and there will be no unit. The reason, see, unit will not be there. The reason is 6 centimeters over 4.5 centimeters. So centimeter is cancelled with centimeter. So refractive index has no unit because it is a ratio between two similar quantities. So 1.33 is the refractive index. In the mark scheme, answer can be anyone because we are not exactly using the same paper. It is sometimes I'm zooming in, sometimes zooming out, so don't worry about that. But we must follow the instructions. The student repeats the above procedure for an angle theta 2 is equal to 40 degree. Now theta 2 is equal to 40 degree. He places two pins P5 and P6 so that pins P5 and P6 and the images of P1 and P2 all appear exactly one behind the other, mean they are in line. Draw a line through the pins P5 and P6, extend the line until it meets GH. Label the point at which this line meets GH with letter K. So GH, P5 and P6. Let's go back to the diagram. GH here, this yellow line, GH, yellow line. Let's see. Line is not very perfect, but no problem, it's okay. So this point is labeled, we will label this point, and also this CD we have to label. Now let's see what the particular points they have given. So GH with the letter K and CD with the letter R. This is K and this is what? R. So K and R. Okay, now let's follow the next instructions by the examiner. He is saying, now measure the angle alpha, where alpha is the acute angle between the lines RK and GH. Means again this is less than 90 degree. So between RK and GH. Now let's see where is RK and GH. Mean here this angle we are supposed to measure. This angle we are supposed to measure. So you can make even again the baseline of the protractor at GH. Center should be at this point and then measure from 0, 10, 20, 30 like this, that line as we discussed it up. And when I'm trying to measure it, answer for me comes to be almost 24 degrees. Now another student suggests that angle alpha should be equal to the difference between theta 2 from EI, theta 2 is 40, and theta 1 from A2, that was 16. So difference between theta 1 and theta 2. So what state whether your results support this suggestion, justify your answer by reference to the values from your results. So alpha is equal to basically theta 2 minus theta 1. So let's place the values. Alpha is equal to 24, theta 2 it is equal to 40, theta 1 that is equal to 16, so it means it's equal to 24. So both are equal. Yeah, okay, no problem at all. So 40 minus 16 is equal to 24. Okay, now statement, yes, because they are equal. And justification, don't say anything else, just say they are equal. They are what? Equal. If they will not be equal, then we will try to calculate their percentage uncertainty. And if it will be less than 10%, we will say yes, they are within the yes, and justification will be within the limit of experimental accuracy. And if they are their difference is much more than, and the percentage uncertainty comes to be above 10%, we are going to write in statement no, and in justification they are outside the limit of experimental accuracy. Now I just want to explain what do I mean by percentage uncertainty. Like, let me tell you, just as an example, for this part, the other option is, let's suppose your value of alpha is 33 degrees. Alpha is 33 degrees. And when we are calculating theta 2 minus theta 1, that is coming to be 16 degrees. That is coming to be what? 16 degrees. So now they are not equal. Actually, he is saying that alpha should be equal to theta 2 minus theta 1. No, there is a difference. Now let's calculate first percentage uncertainty or inaccuracy. So I am writing percentage, U means uncertainty. Rule is you can multiply 2, then difference of the two values in the numerator, 33 minus 16, 33 minus 16 over 33 plus 16 and times 100. So I'm going to do it now. See, it is 33 minus 16 equal to 17 over divided by 49, because 33 plus 16 is 49, is equal to this, times 200, because 2 here, 100 there, it comes to be 69%. So it is 69%. So in this case, now it is the percentage uncertainty is almost 70%. It means your result is only 30% accurate. So what we were going to write in statement in that case? In statement we were going to write no, and justification we were going to write outside the limit of experimental accuracy. Outside the limit of experimental, I'm just using the shortcut, outside the limit of experimental accuracy. So like this. But if this after calculation answer was, let's suppose 9%, then in the statement we were going to write yes, if the percentage uncertainty was less than 10%, like 7, 8 or 9%, 5%, 2%, whatever. So statement was going to be yes, and justification was within the limit of experimental accuracy. So this is in general the rule which we are following to solve this sort of questions where statements and justifications are needed. Now here actually they are equal, because I am doing it just roughly, not accurately on the paper. Here they are equal. So I am not going to write within the limit of experimental accuracy. No need to give that limit. It is exactly 100% okay. Now the last point, suggest one technique to use this type of experiment, in this type of experiment, to ensure the results are accurate. To ensure that the results are accurate. So many answers can be there, but like you can write, there are many pins you need to fix. So view the bases of the pins. Don't see them from the top. View the bases of the pins. This can be the answer. And other answer can be sharpen the pencil. To draw these lines, sharpen the pencil, which also means use thin lines. No paint competition rubbing. Use thin lines like this. Pin spacing should be at least 5 centimeters. So like this, many possibilities are there which we can use. Please, if you have any question, feel free, you people can ask me. So please practice this question yourself again, and if there will be any doubt, feel free, even in the next sessions we can discuss this again. No problem at all.
What does view the bases of the pins mean?
This is a common pin, and the pin style is like this is a pin. Okay, another pin is maybe like this. So if you will see from the top, they will be looking one behind the other. but basically bases are not lined up. So the base here, so always try to see from the bases. Now see, it means this is not perfectly aligned. So what to do, I will connect it actually this way. So one behind the other bases will be there. Don't see them from the top. Like in school, during the assembly or in sports, when you are in line for representing your home or your group, like yellow team and blue team or red team, like this. So when you are standing, so the PE teacher or your homeroom teacher, so they are asking you to keep 1 arm distance apart at least, and exactly one behind the other, mean your feet, and like this they should be in line. So this keep 1 arm distance mean, that's what I wrote up somewhere, that there should be at least 5 centimeter apart for the pins. Distance should be at least 5 centimeter to get more accuracy in your measurements. And you should not see from the top. Always view the pins from the bases. If the base is in line, so it means top will also be in line. Viewing pins from the top means somebody may be just leaning forward, right, left, like this. So no, that will not be workable. Okay, now we will be moving to next question, which is based on planning. A student investigates the speed of a small trolley moving down a sloping ramp. Plan an experiment which will enable her to compare the effect of the different angles of the slope on the average speed of the trolley between the points on the ramp. Now, my dear friends, one thing which is important here, in this sort of questions, we must be looking at what is independent variable and which one is dependent variable. Now, independent variable is the variable which is controlled by the student or by the teacher while performing that experiment. Independent variable here is the angle. As you will change the angle of that slope, definitely it will affect the speed of that trolley on the ramp. If this angle is higher, so the speed will be greater, mean its gradient will be more, slope will be more. And if the angle is smaller, the speed of the trolley will be smaller. So independent variable in this case is the angle of the slope, and dependent variable is the speed. Average speed is the dependent variable. So the variable which is changed by the teacher while performing the experiment, or the variable which is changed by the student, or the physical quantity which is changed by the student while performing the experiment, that is independent variable. And as a result of that change, the other quantity related, linked, is changing, so that will be the dependent variable. Now average speed can be found by distance over time, or total distance traveled over total time taken. Total distance traveled over total time taken. The apparatus available include, the apparatus which is available to the student, it is a long ramp with a support that enables it to be set at different angles of the slope, a small trolley. And now that ramp with a support mean there will be some blocks. So increasing the number of blocks, it means we are increasing the angle with the horizontal. We are what? Increasing the angle with the horizontal. Are you with me what I'm saying? So this apparatus is available. Now in your plan, first of all, we will be trying our best to hit or focus on the points given. Like in your plan, list any additional apparatus needed. We need 2-3 things, by the way, I will tell you, because we need to measure time. So it means we need stopwatch. We need to measure distance. It means we need to use meter rule or tape measure if this is longer one, ramp is long enough, and then also at the same time we need to measure angle, which is independent variable, so it means we need a protractor D. So these three apparatuses are needed, but we will come to this one. Then explain briefly how to do the experiment, including how to take measurements so that the average speed can be calculated. Then suggest a possible source of inaccuracy even if the method is carried out carefully. State the key variables to be kept constant. In other words, for a fair test, what are the quantities to be kept constant if different students at different places in different schools are performing the same experiment. Draw a table or tables with column headings, and to show how to display the readings. You are not required to enter any reading in the table. The reason for that, you are not performing this experiment during the exam hours. You are just following the instructions on the basis of your experience. So, and explain how to use the readings to reach a conclusion. Mostly we are plotting a graph between the two quantities. Independent quantity comes on x-axis and dependent quantity is on x-axis. So this is basically the requirement or the key points which we need to focus, and we will try to write the answer in the form of a paragraph instead of writing in bullet points. So let's start one by one. List any additional apparatus needed. So we need we can say that protractor, of course. First of all, we will go with the independent variable protractor, then meter rule and stopwatch. And stopwatch are needed to find the average speed of the trolley. No, I'm not that much good in spellings. Trolley spellings are double L-E-Y. Of the trolley moving down the slope. Slope on a ramp. Now dear friends, no need to write this all by the way. Even you can write, if you don't have that much enough time, so only that will be enough that protractor, meter rule and stopwatch are needed to perform this experiment. Up to here it will be okay, workable, but I just wrote a bit more. Now next point is briefly explain how to get this result. Now always start with the independent variable, that is angle. So measure the angle of the slope with the horizontal also measure the distance between two marked points on the ramp, and measure the time taken by the trolley, measure the time taken by the trolley to move between the marked points. so marked points, then you can find the speed. Write this formula is equal to distance over time taken. But always remember, when he is saying briefly explain how to proceed this result or this experiment, now you are not going to take only one reading. You can say repeat the same method. This is part of this by the way, briefly explanation of the performance of the doing of the experiment. So repeat the same method or procedure, same procedure for different angles of the ramp. You know, independent variable we will change, dependent will change itself. Same procedure for different angles of the ramp. Now what is the next point? Next point is list any additional operators. Second point, we did not suggest a possible source of inaccuracy if the method is carried out carefully. No, it means something wrong with the operators or some personal error, like its reaction time error can be there. What is a reaction time error? You did not start the stopwatch as the trolley reaches the first mark point, and you did not stop the stopwatch exactly at the point, at the second point when the trolley crosses that point. So you can write here reaction time error. You can also write here the surface of the ramp is not smooth, irregular surface you can say, and like these points. So they want source of inaccuracy, possible source of inaccuracy. It's not true. So I will go with this, you know, stopwatch is in action, so I will be writing for this reaction time error. Reaction time error to start or stop the stopwatch at the marked distances. Marked distance is enough. Okay, then next point is key variable to be kept constant. We can say key variable to be kept constant, my dear friends. I will go with that the distance between the marked points should be kept constant. Yeah, distance of the trolley to move, distance between the marked points on the ramp must be kept constant. Okay, now what is next point? Let's follow the instructions. Yes, draw a table or tables with column headings. Draw a table or tables with column headings. Here we need just one table. So always start with independent variable. So I'm starting with independent variable, that is angle in degrees, then distance in centimeters, then of course time in seconds, and then of course we need speed, which is independent variable distance over time, and unit is meters per second, and that is enough. See the independent variable in the beginning, dependent variable in the end, and how to get that independent variable. You can add this independent variable is average speed, which is total distance traveled over total time taken. So distance over time you can add in between independent and dependent variable. So this is the thing for next. So now Of course, the next one will be how to reach a conclusion. How to reach a conclusion. For that purpose, dear friends, that plot a graph of average speed on y-axis against angle on x-axis. Always you can add one thing when you are plotting a graph, so you need a lot of values. So repeat the experiment. Last one you can write that repeat the experiment to get at least 5 sets of data. And he did not ask this one, but as a precautionary measure you can say this one also. So in this way this question is done, and dear friends, we solved it first time. This question started from 2016 onward. Now every year this question number 4 is the last question in general in paper 6, and always it is of 7 marks, and you have to focus on the points, the bullet points given by the examiner in the question paper. You have to focus on them in order and try to write it in the form of a paragraph, just like you are doing an assignment, to go with the continuity of the assignment. Don't write every point separately. Stay blessed and thank you.